So in this video, I'm going to discuss the Fibonaccharsis, somewhat like that. That problem which occurred in today's CODEFORCES challenge. So if you have any doubt regarding this, you can ping me up on Instagram. Even you can join my Discord server. I will provide both the links in the comment section. I'll pin them. So the problem is very simple. It is given that you're given two numbers n and k. Sorry, let me focus it once. So you're given two numbers n and k, and you have to find out a Fibonacci series of size k such that the kth element is n. Okay, so how many ways can this be done? Like basically what you mean by a Fibonacci series is that you're fixing the t1 and t2, and the remaining things are going to follow this formula, right? This recursive formula, if you know the Fibonacci series. So it is all about fixing the t1 and t2, right? Now you have to find how many ways we can do this. So how many ways we can fix t1 and t2 such that t of k, let me rewrite it, so such that t of k is equal to n. Okay, so how many t1 and t2, how many pairs of t1 and t2 are there so that t of k is equal to n? But remember one thing, there is a very important concept, that is t1 should be lesser than equal to t2. That is very much common, like you guys know it. So now let's talk about the formula. Okay, so now if we know that t1 and t2 is over here, so let's say the series is like a b c d e f g h, right? Somewhat like this. Now the calculation part, notice it very carefully. C is equal to what? A plus b, right? A plus b. D is equal to what? C plus b, that is this plus b, that is a plus b plus b, that is 2b, right? What is D? D is C plus B, right? E is D plus C, right? So this and this is 2A, and this is 3B. What is F? F is E plus D, right? So this and this is 3A, and this is 5B. So if you notice one thing very carefully, you will notice that this, for every term, this A, the coefficients of A and coefficients of B are also in a Fibonacci series. See? For this it was 1a 1b 1a 2b, right? So 1 1 1 2. So for b it is 1 2 starting with 1 2, and for a it is starting with 1 1. So 1 1 1 plus 1 2 2 plus 1 3, because the previous two terms, right? So this is what the coefficient of a and b are going to confirm. We can like observe in this situation. So what we can do is, for a we can run a loop where a is equal to, from let's say from a is lesser than n, a plus plus. Okay, so for all the elements for a, you have to check whether it is possible that the nth element is that or not. Like let me tell you that the constant was given that the n was of somewhat 10 to the power 9, I guess. But remember one thing, I think n was 10 to the power 4 or 10 to the power 5 something, but k was almost 10 to the power 9, right? Yeah. So this was almost 10 to the power 9. But remember one thing, that if nth term is 10 to the power 5, then why do we even need that of k 10 to the power 9 order? So if at any position, if you feel that k is greater than n, so you can obviously return false directly, right? I mean, by false I mean you can obviously say that there are zero possible cases, right? So you don't need to consider the remaining cases. So you can like reduce this 10 to the power 9 to 10 to the power 5. So it was 2 into 10 to the power 5. Okay, so you can reduce this to 2 into 10 to the power 5. Okay, so now since we are done with this, or you can even write 10 to the power 5, it works. So now we are done with this. So we have to do one thing, pre-compute the Fibonacci for A and B. Okay, for A and B. But like if you notice one thing, so it is the same thing, like 2 2 3 3 5 5, it goes like this. So you can either compute for any one, or if you want, for you, like for your better understanding, you can do it A and B by using this recursive formula. And this is basically a kind of dp. Okay, a dp, like dp of n is equal to dp of n minus 1 plus dp of n minus 2, something like that. Okay, or you can replace n with I because you are going to run a loop. Okay, so you can do this for all the values from 1 to 10 to the power 5, right? So now since you're done with this, so you have to find out, since it is given that it is going to the nth term, so let's say this is n, sorry, that is going to be a kth term, sorry, I just misread it. So since let's say n is equal to a of k, right, a of k into first term plus b of k into second term, right, second term. Now if n minus a of k into first, that is n minus, so let me rewrite it, let's say it is ARR and BRR, okay, for your better understanding. So pre-compute Fibonacci for A and B means for A the pre-compute will be ARR and for B it will be BRR. Okay, so let's say if n minus ARR I into A is divisible by, what should be divisible by? It should be divisible by B into, sorry, B of K into B, right? B of BR of K into B, right? So if it is divisible by BR of K or not, sorry, this is not I, this is K, right? So you have to check it, and if it is divisible, you have to also check that this term, because since if it is divisible, like let me, I think it is getting very much clingy over here. So n is equal to ARR of I into A plus BRR of I into B, right? So what you can say about B is going to be n minus ARR of I into A by BRR of I, and when I am telling about I means K, okay, I means K. So sorry, let me rewrite it as K only for better understanding. Okay, so let's say this is K. So n minus ARR of K into A by BRR of K. So what is the first condition? This should be divisible by this. Okay, first condition. And the second condition is A should be lesser than equal to B, right? That means, so this is B, so this should be greater than equal to A. Okay, n minus ARR of K into A by BR of K should be greater than equal to A, and n minus ARR of K by BR of into A by BR of K should be divisible, sorry, n minus ARR of K into A should be divisible by BR of K, that is, so that this is a whole number, this is a integer because B is an integer. So what is the first case? You have to find B is integer, that is divisible by BRR of K, and the second case is you have to find that A is lesser than equal to B. Okay, so this is the main thing. And how you are going to find this? So I have told you that this is B, so it should be greater than equal to A, so that is n minus whatever, this should be greater than equal to A. Okay, so this is the two conditions. So if both the conditions satisfies, so you can say that there is a Fibonacci series that exists. So if both of the conditions satisfies, you can say that result plus plus, and at the end you have to return result. Okay, you have to return result. So this is a very complex explanation of this problem, but this problem was like, if you understand the basics of this problem, so this is very much logical. So that's it from my side. Thank you.